Hello again. This is part 2 of the demos I talked about in part 1. And in this part, I'll be showing, we will be doing a demo on how to use the microcontroller in the sleep mode and configure the Watchdog timer to wake it up every amount of time. Okay, so demo 2 about sleep mode and Watchdog timer. If you remember, the structure that shows the clock source that feeds the timer 0, we said that when timer 0 is not using this prescaler, the Watchdog timer will be using it when this PSA bit is 1. So the timer 0 will be using the clock as is, and this will be free, and it will be assigned automatically to the Watchdog timer. And in the option register here, the option register, this bit, when it's 1, the PSA is assigned to the Watchdog timer. Okay, then these 3 bits will decide the amount of prescale. The default of these 3 bits are zeros, so the default is 1 to 1, so no prescale. Okay, we know from the data sheet that the Watchdog timer overflows every 18 milliseconds optimal. This is from the data sheet, okay? And the Watchdog timer, when it overflows, it can either cause a wake up if we are in the sleep mode, or a reset if we are, or the microcontroller is the normal mode. We're going to use it for wake up when we're in the sleep mode. Okay, 18 milliseconds is the fastest time to overflow. Okay, the slowest time it will be when we have these prescaler bits, the PS0, 1, 2, and 2, 1, 1, 1. In this case, the prescale will be 1 to 28, and 128. So 18 milliseconds times 128 will be 2.3 seconds. Okay, 2.3 seconds, around 2.3 seconds. Well, we need something around half a second, so maybe a prescaler 64 will be around 1 second, maybe 32. Let's try 32. 32, so 0.018, 18 milliseconds, times 32 will be 576 milliseconds. So that should do it for our example. So a prescaler of 32 will be 576 milliseconds. So if we prescale the Watchdog timer 1 to 32, we'll have it overflow every 576 milliseconds to wake up the controller from the sleep mode, do something, and go back to sleep. Okay, to remind you that to put the controller in the sleep mode, we had an assembly instruction called sleep. Okay, and to make sure the Watchdog timer starts counting from 0, and to clear it at any time, any point of time, we use an instruction called clear Watchdog timer. Okay, so these are the 2 instructions we'll be using, and the option register in our example will be the option register will be use the prescaler with a prescale of 32, which is 101. So 101, and we don't care about these bits now, right? So on 8, right? 8D, right? 0x8D. Okay, let's go write our program. This is the previous project. Let me close this, start a new project. New project. Next. Let me create a folder for it, call it sleep mode. sleep mode. Okay, sleep. Next. Okay, so what we want to do here first is to use the prescaler and assign it to the watchdog timer. So the option register will be, as we just calculated here, will be 8D, 80x8D, and this we did use the a prescaler scalar of 32 for the watchdog timer, causing it to overflow every 18 milliseconds times 32, which was equal to 576 milliseconds. Great. Before that, maybe we want to clear the watchdog timer to make sure so it doesn't overflow while clear watchdog timer. To write assembly in C, we can say ASM, assembly, okay? Clear watchdog timer. And maybe clear it. Well, what do we want to do? Let's try to blink the LEDs on port C. Let's try to blink the LEDs on port C and port B. Okay, so let's configure port C as an input port. Okay, as an output, sorry, 0x00, and maybe port B 0x00. Initial value for all of them port C equals 0x00, port B equals 0x55, maybe, to have every other LED blink. Okay, clear the watchdog timer, assign the prescaler. Now we can go forever while one forever. Flip port B equals tell the port B, the complement of port B. Port C equals the complement of port C. Then sleep, assembly instruction, sleep. Okay, that's it forever. Flip complement port B, port C, go to sleep. Who will clear it? Who will wake us up? The watchdog timer after around 576 milliseconds. Let's try to build this and program it. We don't need to we have not to forget. Let's build all. Okay, program it. We need to enable the watchdog timer. Well, I started programming before I configure this, but I'll wait for it. Okay, enable the watchdog timer. Otherwise, it's not going to wake up. Okay, see, it's programmed. Let me show you. I'm going to enable it now. If I share my camera here, how do I do that? So camera. Okay. Okay. Well, the watchdog timer is disabled. So what happened, I see on my board, is that all the LEDs I turned on are on, and that's it. Nothing is happening. Okay. So port B was 55. The while loop flipped them, so it's AA, and port C was 0. I flipped them, and now they're all on. Then we're in the sleep mode. Nothing waked us up. I need to go and configure the Watchdog Timer, enable it in the configuration word, and write the program again. Now it's working. Let me stop sharing over here and share over here. Okay, so as we see here, the port B and port C are both blinking. Port B, every other LED is blinking. Port C, everything is blinking. And if you remember in the code, we did not use any kind of delay. We just turned on the LEDs and then started flipping them every loop. But in every loop, we go to sleep, and there is something that wakes us up after around half a second. And to see the timing, I connected this scope here on port C to see how long it stays high and how long it stays low. You can see it on this oscilloscope. So the time high, time low is around 500 milliseconds. It is actually 576 milliseconds. Okay. So this was for demo 2. And to remind you that we did not use any delay here. It's only the sleep instruction. And what wakes us up is this prescaler, is this Watchdog Timer that is caused to overflow every around 500 milliseconds. Thank you, and see you in part 3 for the third demo.